Hello guys, in this video we're going to be learning about how to solve equations using the cup and the algebra tile method. The first thing I want you to make sure you write down is that anytime we're dealing with equations, both sides are equal. So what you do to one side, you have to make sure you do to the other. If you don't, you make, instead of it being balanced, you make it not be balanced. So we need to make sure that anything we do to one side, if we add something, you add it to the other side as well. Let's take a look at this first example, guys. We have x plus 5 equals negative 7. The first method that we see is the cup method. In this case, the cup is going to represent any variable. So if you notice for this one, for the x, I have 1 cup on the left-hand side. So there it is, and then those 5 plus 5 I've represented with these 5 open circles. On the other side we have negative 7, which is why I have drawn 7 closed circles. From here, it's very similar to how we were using number tiles to add and subtract integers. We're going to use the same concept here. So in this case, I have 5 positives on the left-hand side. To be able to move them to the other side, I need to be able to cancel them. Therefore, we're going to be using kind of like what we did with 0 pairs. So if I add 1, 2, 3, 4, 5 negatives to this side, I can also add 5 negatives to this side. 1, 2, 3, 4, 5. Therefore, if I add them, because I can make these 0 pairs, going back to those tiles, that basically cancels. So I'm left with just 1 cup equaling, and then I can count all of these to see what I'm left with. I had 7 negatives, I added 5 more negatives, so I now have 13 negatives. So basically this cup, what it represents, it would have 13 of these negative little circles. Underneath, it's the same process, guys, but now these are called algebra tiles. In algebra tiles, the rectangles represent the x's, and then we have positives and negatives. They might show you in color. If this was the STAR test or the tax test, of course they won't show you color, so they might show a plus inside and a minus for the other one. I'm not doing that, but I'm just showing you in green and in red the negatives. So same thing, to be able to cancel and make 0 pairs on this side, I need to add 1, 2, 3, 4, 5, because these 5 negatives are going to be canceling these 5 positives. And if I did that to that side, I also do it to this side. 1, 2, 3, 4, 5. So I am left with just 1 x tile. Oh, by the way, the equal sign can be represented by 2 things. It could be represented by this line that's here. That line will represent the equal sign, or they might actually show the equal. Okay, just wanted you to take note of that. So in this case, we have 1 x, and then the sign. The sign is equal to. So that line means is equal to. And on the other side, if I add all these up, again, I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So basically here, I'm left with x is equal to negative 13. Just like I got it with the cup. Okay, the next example, guys, it's a little bit more tricky just because I have x's on both sides. So right now, I have 3 x's being here represented by the cups, and then I have the positive with the open circle. I have an x on the other side and 7 positives on the right hand side. So to be able to solve this, the step that's a little bit different from what we were looking at in the first example. Just like when we were trying to get rid of the positives and the negatives, here we're going to try to get rid of the x's. I can take away one cup from both sides because I have a cup on both sides. So if I take this away, I'm still leaving my equation balanced. I still have both sides equal to each other. Then, since I have positives on both sides, I can take away one positive from both sides. So from here, we are left with 2x's, which is equaling 6 positive 7. So if I wrote that, I am basically left with 2 cups, which is equaling 1, 2, 3, 4, 5, 6, 7. Well, here, guys, we would actually not be able to split it up half and half. We would be able to fit 3 of these in here, 3 of these in here, and then this one, if possible, right? In this case, I mean, there's really no way to break a coin in half, but if we were able to, we would have each of these equaling 3 1/2, because you want it equally to fit into both of the cups. So basically here we have x is equaling 3.5. That would be my answer. Okay, now on to the algebra tiles. It's the same process, except I have these rectangles which represent the x's. So I have 3x's plus 1 positive. On the right hand side, I have 1x and 7 positives. So same thing, I want to see what I can cross out. Well, I have 1x here and 1x here that I can take away. I have a positive and a positive that I can take away. So, same thing, I'm left with 2x is equal to 1, 2, 3, 4, 5, 6. Oh, that's where I messed up. Sorry, guys. Backtrack. That previous example, I took away 1, and that's why I messed up. So, actually, this answer would be 3 in each one. So, let me fix that. It would be 3 because we took away the 1 and I drew that wrong. So, sorry. Go back to this example, guys. We take away one of the positives and I am left with 6 positives. Therefore, each of the little rectangles must equal 3 for that to equal 6. And that's it. So go ahead and take a look at I want you to try these with using both the cup and algebra tile method. Try them on your notebook, see if you can get it. I'll tell you the answer in a little bit. Go ahead and put pause on the video so you can try it. I'm going to give you the answer in a little bit. Okay, so hopefully you were able to solve both of these. For the first one, we actually get a fraction. Each of the x's is representing a half, and then for number 2, each of the x's ended up representing negative 2 tiles. And to finish off, I want to show you some of the STAR test problems that are related to this. For this one, this was from the previous STAR test last year. They gave you these model and they wanted you to solve for x. If you notice, they did throw in some fractions in there. Not always will you have perfect answers. So in this one, guys, same thing. We cross off the x's. I'm left with the 3 x's over there, and then I can cross out positives. So I'm left with just these 2 and then these 3. And in order to do that, we actually have to figure out how much of this, how can we split them equal into these 3. So since we have 2 and we're splitting it into 3, each of these is actually worth 2/3. And then let's go ahead and look at the next one. Okay, guys, in the last problem, this is from to the 2009 tax test. Again, we're going to try to see what we can cancel from both sides. So I can take away 2 x's from both sides, as well as 2 positive ones. And so now I have just 1x equaling 2. So therefore, the correct answer for this one would have been J. Remember, guys, jot down any questions you might have for me. We'll discuss this further in class, and then we'll practice also in class with the whiteboards.